Let's now take a look at the way for us to multiply and divide numbers written in a polar form, and more importantly, what it means in terms of what is happening on the Argand plane. Again, let's start with the generic points z and w, now written in a polar form. So z is r cosine of theta plus sine of theta I, and w is s cosine of alpha plus sine of alpha I. You already know that the modulus of z is going to be given by r, and the argument of z is theta. Same thing goes now for the number w. All right. So what is going to be z times w in polar form? Here is the expression. How do you get it? Well, you can just cross multiply the r. This is going to be r cosine of theta plus r sine of theta I, and this is going to be s cosine of alpha plus s sine of alpha I. If you're multiplying, then apply the rules of multiplication that you learn in lesson 2. You'll have 4 terms, and then you can work it out and use the rules of trigonometry, and eventually reach to this formula. That's not important bit. What I need you to focus on is the result that you have to apply and what it means. So this is going to be equal to the product of the moduli of each one. All right, r and s is the modulus of z and the modulus of w. They are multiplied. Okay, and then what is happening to the argument of z and w? If you look at it over here, what is happening? The argument is going to be given by this, and what you are basically doing is adding this and that. So the argument of the product is the sum of the arguments of the individual numbers. Now let's stop over here before going to division and understand what this means. Let's say again that we start with random numbers z and w. Okay, so r is the modulus of z, theta is the argument of z, s is the modulus of w, alpha is the modulus of w. If you are multiplying these numbers, first, what is happening to the modulus of the product? Is being multiplied. So it's going to be much bigger, the outcome number, than any of the previous one represented here in this dashed line, just for reference. Okay, it's going to be much bigger. How bigger? Well, it's going to be an enlargement by scale factor s if we are focusing on r. S, I mean the modulus of s. The modulus of s is for w, yes. The modulus of w if you are focusing on the modulus of r. If you are focusing on the modulus of s, is going to be an enlargement by scale factor modulus of z, which is the r. Okay? Basically, this is telling you how much bigger this one is going to be. Okay, you already know this is vectors. We've been dealing this for a long time, since at least Math AS. What about the argument? If alpha is the argument of w and theta is the argument of z, then the argument of the product is going to be the outcome of adding these two. So what are you doing? You are doing a rotation. You are rotating z through the argument of w clockwise and about 0. This is what you're doing. Or you are rotating w through the argument of z, which is theta, clockwise about w. In simple terms, you are just adding this to this. This is going to be the overall argument. So, doing a product of two complex numbers in polar form, you are doing what? You are multiplying the moduli of each number, and you are adding the arguments. What if you are dividing? Again, you can do it yourself, have fun with that, but eventually you will end up with this result. So now what is happening? What is happening to the overall moduli? Is going to be the outcome of the division of the moduli of each one by the other one. What about the argument? Now it's going to be the difference of the angles. So again, this is where you start with. So what is going to be the outcome number? Is going to be smaller, right? So you are enlarging, technically still an enlargement, but now the scale factor is 1 over the modulus of s. Actually, there, I should just write s. This is the modulus of z. No, this is the modulus of w. This is the modulus of z, which is the s and the r. I should take these moduli in a bit. Okay, but again, is the scale factor is 1 over the modulus of w, and here we are enlarging. Again, technically speaking, is an enlargement s of s by scale factor 1 over the modulus of z. Okay, so technically is becoming shorter. What about the argument? Now you just subtract the arguments of them both. Okay, so the argument of z over w is a rotation of z through the argument of w anti-clockwise about 0.0.